can't believe I forgot about that. I planned that out at the beginning of the year. I need to make a rubric and some guidelines for y'all, though. I don't need to just turn you loose to go do it. I'm going to have to make sure that you have some rules so that you're like not bit about it. Hey, folks, it is March the 29th, and today we're going to start our first lecture on world geography. I posted the notes in the Google Classroom for everybody so you can keep up. We're going to go through about 10 or 11 of these slides today, and then the class is going to spend some time with an introduction to Study Island, or reintroduction. And for those of you who are at home, you've already been given your assignment. So if you haven't finished it, you should do it. If you're having problems with it, you should email me. So there we go. So much sunlight. All right. So in your book, we ended off, talking about the cusp of what we call the Age of Revolution. And so the Age of Revolution coincides with something we call industrialization. Wow. Okay. So you're going to have political changes come with economic changes. And if there's one thing that that we go over with my economics students, my seniors, is that economics is tied very tightly with your freedom, with political freedom, religious freedom, your ability to own property or your labor. Yeah. Like labor is like what you do. You know, you work for things. You do like something and you get paid for it, or you get trade for it. That's tied with your freedom to make so many other choices in your life. A guy named Hayek wrote a very, very impactful article on that. Hey, Jake, we're going to close that. We're going to do that stuff later, y'all. I'll give y'all time for that later. So, I'm not talking to nothing. So the age of industrialization is going to have a big part to do with this. But at the same time, the West is going to become so powerful in its industry that it's going to use the things that it's learned from industrial warfare and also from the many new sciences that are coming up to dominate the world for a short time. And we're going to see this culminated around a lot of the great powers within Europe, Great Britain, France, a little bit from Italy, the Dutch, some of it from the Germans, who are going to be the new kids on the block.
So somebody makes a scientific discovery, and the government's just like,
Typewriter.
can we let them?
Well, this is one of those things that we find even with ancient people. Technological advancements in warfare lead to them spreading the boundaries of their country. It happened with Egypt because Egyptians were like the best at making chariots for a long time. Whenever you have countries or people go into the Bronze Age before their neighbors, they dominate their neighbors. Before they go to the Iron Age before their neighbors, they dominate their neighbors. You know, it's look at like the Huns or the Mongolians. Like they had a mode of warfare that was very effective. And what they do? They went out pillaging. So, all right. So, some terms you should know how to use: industrialization. Oh, wait. I'm giving y'all the 10th grade lecture. I messed up, man. Y'all should have told me.
I like industrialization.
I know. It's the
I found learning about this stuff.
Yeah, I was just thinking, wait a second. We didn't end off talking about Louis the 14th.
They hate
and stuff like that.
Congo too.
I found learning about that stuff.
See, my thought was,
Mr.
did you
White.
guys have a lecture on
Mr. White.
something?
Why are we learning about typewriters?
I'm talking about the wrong class.
Mr. Wagner.
Yeah.
I take my notes.
Yeah, if you take notes on that, that's fine. Yeah, I'm sorry, kids. I was giving y'all the wrong lecture.
Well, like sometimes when we go over the industrialization and stuff.
I mean, if y'all want to go over this, I can send it to you. But
You should have titled it and this
Yeah.
lecture.
no.
Geography unit.
Well, you know, at some schools they mix it up to where like it doesn't have to be in order. Like you could take your world geography a little bit later and your world history first if you want to. It's a little confusing. All right, yeah, so we're geography unit 1, my bad. Yeah, but
Industrialization.
man, yeah, like
Free enterprise.
yeah, we can't skip from the fall of Rome to industry. Yeah, that like shows where my brain's at right now. It's the last thing I was thinking of, so I continue the thought. Okay, so geography unit 1. So
This needs to-
It's not like we skipped, what, 1,700 years?
enough of it, yeah. Well, no, not that much. More like 1,400. So or 1,200. All right, so geography. Geography comes from Greece. At least the term does, the word. So we have geo from the word world, and graphy, which means writing. So this is essentially a way to write down, and when we write things down, we're communicating an understanding of something. So this is how we communicate our understanding of the world around us. Geography it's kind of like one of those things that has characteristics of technology, it has characteristics of science, but it also has characteristics of a bit more of the subjective arts, such as history and sociology, things of that nature. Because largely when it comes to understanding human beings, especially groups of human beings, when you're an outsider, when you're somebody from one part of the world and you're trying to understand groups of people's lives that you're studying, but you're not one of them, it's subjective. There are subjective elements to it. You try to do so through a scientific way, but we all make mistakes. So one of the important parts of understanding geography is location. Location is simply where something is. So we all understand location and use location all the time. Whenever somebody says, "Hey, where are you at?" You might say, "I'm at school, I'm at home."
This geography unit 1.
Yeah, and this is all in the Google Classroom. If you have trouble following along, I posted it as a PDF. We have absolute location, and it's absolute because it's more definitive. It's more measurable. Describes the exact location of a place, often described using latitude and longitude. Or if you're not even talking about a geographical place, you could think of X and Y axis, and sometimes Z axis if you're talking about up and down, height. Like you might use this in math, you might see it in a video game. You have relative location. Describes where a place is in relation to something else. So Europe is north of Africa. You could say, I'm around the southeast side of Tyler. But if you want to use the more exact absolute location, you would give the school's address, which is something grande.
It's 4201.
Oh my gosh, man, I've got crazy memory. I remember when I was a kid, I had so many addresses and telephone numbers memorized, but we didn't have internet and we only had landlines, so you had to. So out of necessity, I had to memorize a lot more things as far as that goes. But now that I'm older, and I'm just like, boop, boop, boop. Okay, I'm here. Or yeah. Especially when you're little, a lot of parents back in the day would get our little first wallet, right? Little Velcro cheap wallet. Oh, look at that. And so mom or dad would write down home address and phone number and stuff in it in case you got lost or something like that. And I did get lost a lot because I was pretty much whenever it was summer, even when I was 6, I'd just take a walk off in the woods and disappear. And eventually found my way back home before dark. So it's location. Y'all know location. Y'all know location. But yeah, if you get behind Jaden, what I would do is I would split screen, open tab, have a window. You can have this on one side, that on the other, or you could just copy and paste it. All right, so hey, I thought I got rid of the animations. Oh man, I hate these animations. All right, so latitude and longitude. So for a lot of us, we don't use latitude and longitude daily. Latitude and longitude is very important for geography, however, and it's also really cool for map reading. I wish it'd be really cool if we had a lot of property out here and we get some lensatic compasses, get some protractors and some maps and tell you, here's a plot on the map, go find it. And if you get something called your pace count, where you memorize how many steps it takes for you to walk, say like, I don't know, 100 meters, and then you can know how long it takes you to travel somewhere by time. What's the distance? With the compass, you can get the direction. With your map and your protractor, you can tell what direction you need to go and what visual markers you get. And then voila, you can find yourself on the map and you can find where you want to go and get there, even if you can't see your endpoint. Which is pretty cool, pretty cool. I don't know if scouts still do that. I was never a Boy Scout. But a lot of the military still teaches that, just in case, gadgets don't work, because sometimes they don't work. Bless you. So latitude. Lines of latitude are measured north and south of the equator. You see that latitudinal lines go left and right. They go left and right because if you think of the ticks on a ruler, you have to pass each tick to get a measurement. So you have to pass each line of latitude to get
I
your
thought
measurement.
latitude was going up and down.
You measure up and down, but the line goes left and right.
Oh,
Same-
yeah.
yeah.
And then longitude.
Yeah, longitude.
Or long.
So lines of latitude, they're pretty ancient. People were able to measure these pretty early on within human history. But lines of longitude, they're not going to be able to actually measure those until they get super accurate clocks. In fact, I don't think that the standard lines of latitude or longitude were discovered and measured until like the 1800s by the British. And that's why 0 degrees longitude is going to start in Greenwich, England, or Greenwich, where they have some clock or another. So lines of latitude are measured north and south of the equator. The equator is 0 degrees of latitude. Other lines of latitude are called parallels because they are parallel to the equator. Lines of latitude are measured from 0 to 90 degrees north latitude. So you see there at the top and at the bottom of the poles, you have 90 degrees. And from 0 to 9 degrees south of latitude. So like if you're sailing or something like that, that can be very important. If you don't have your bearings, if you're not going to the right longitude and latitude where you want to go, you might get lost at sea. And that's no bueno. No one wants to do that.
Lord.
Well, I mean, I guess like there might be somebody out there, but so you need this for measurements. All right, so longitude. Lines of longitude are called meridians. So we have parallels and meridians. The prime meridian or Greenwich meridian is 0 degrees longitude, and that starts in England. And they're the ones who gave us the lines of longitude, so they got to start it, right? It's kind of like a discovery. Now remember, these lines aren't magically set, laser etched into the earth we live in. They're arbitrary. Mankind made these, and we all agree that they're there so we can have a standard means of measurement. Kind of like borders between countries. Countries agree on the borders, and we just live by the border. That's why you might have like parts of the world divided up. Even though there's nothing there to divide it, we agree on it. It's the same with these units of measurement. All other lines of longitude are measured east or west of the prime meridian. I think I just said that. You see the lines go up and down so we can measure east and west. Each time you cross one, you're further along one direction or the other. Longitude is measured from 0 to 180 degrees east and west from the prime meridian. These lines meet at 180 degrees. This is called the international date line. And this, of course, is where what we call the time zones will start with the first part of the day for the world. This line is both east and west, so it's a little confusing at that part. And we will talk about time zones later. Time zones are kind of like a mixture of, it's like a mixture of course, the movement of the sun, but also agreements that countries or even states have with one another. If you ever look at the time zone map in America, it's kind of jagged. Well, it's the same way with time zones across the world. It's because sometimes if you just have these lines go straight up and down, it's going to be very confusing for some countries or even for some states.
Eastern.
But we'll get to that.
I'm writing all of that.
You're writing all of that?
Yep. Wow. I answered so much.
Of course, one thing I want you to notice, like, see how the lines meet here?
Well,
Lines of longitude have a very large space in between one another whenever you're around the equator. However, once you're near the poles where they meet, it's a very, very small space. So,
That one,
my hand.
well, I mean, it does, but it makes certain things like airplane travel and some naval travel, if they're like close to the poles, they have to use different kinds of maps so that they don't get all the directions all messed up longitudinally. So, all right, no. All right, so the global grid using latitude and longitude. So now we know that this isn't how the Earth actually is. See how it's spread out flat like that? Well, if you tried to wrap that up into a globe, it wouldn't work. It could make like like more of a cone or something like that even, but it couldn't make, or a tube even, like a paper towel tube, but it can't make a globe the way it is. But we spread this out for a better understanding of how latitude and longitude work. You see, it's a grid pattern just like you'd see in math, and you see you can measure through both lines of longitude and latitude, and that brings us to coordinates. Every measurement using latitude and longitude has a set of coordinates. And you see how these numbers are all double digit? Like you got plus 30 and minus 90. Well, you can extrapolate on that. You can go to decimal points to find more exact locations. Like if you were going to say, I'm at 30 degrees plus and 90 degrees minus, well, that would still be like an entire state in the United States. Looks like it'd be Mississippi, but that doesn't tell you where in Mississippi you're at. So that's where we go to decimal points. One coordinate will be for degrees latitude, north or south of the equator.
Like a number?
Yeah.
Oh.
So example, 30 degrees north latitude is this line. See, this line here. This is 30 degrees north, this red line. 30 degrees south is this negative line. And of course, 0 is the equator. And here's the prime meridian going through England. The other coordinate will be degrees east or west of the prime meridian. See, this had an animation, but I turned it off because it was really cheap. So east of longitude, 30 degrees east is right here. 30 degrees west is here. So if you don't know your cardinal directions, north, south, east, and west, it wouldn't hurt to know. Like the front of our school is pointing north. Oh, no, you're right. Yeah, the front of the campus is pointing north. Yeah. I was thinking.
Will it be degrees?
Yeah, the front of our campus is pointing north.
Jesus.
Grande goes west and east.
And he's been drunk for how many years?
I was thinking about the old building. Yeah, the front of the campus points north, and Grande goes west and east. Yeah, so.
And it should be the sun.
Yeah. So,
Something that's going down.
but if you're looking at a map, just always know that north is the top, south is the bottom. east, and west. If you're ever going to do something like navigate, like let's say you're sailing, or if you want to do land nav, or you're walking, or even if you're driving by a map for some reason, you always want to orient the map wherever you're facing. So if you know you're looking towards the north, you want to face your map to where it's facing the north in front of you. If you're looking to the south, you're actually going to want to turn it upside down so you're not confusing yourself. You put the two together and you have a location. So here's our example. You have 30 degrees north. See, it's north of the equator, up here on the 30 line, which is red, and 30 degrees east, which is this purple line right here. So latitude should always be listed first. Your north-south will be before your east and west. So, see. All right, so now we're going to look and see if we can find the latitude and longitude of these following cities in Australia. So,
Oh, man.
so what do you think? Like, I understand that the lines are behind the map, but what do you think the latitude and the longitude is for Alice Springs?
It's in the center of the
It's in the
outback.
center. Yeah, well, yeah, like that's probably a very dry place to live and hot.
What a way
So,
to die.
if it's called Springs, maybe there's some source of water there.
There's just a well that's empty.
So, what do y'all think?
He's speaking upside down.
I think it's a well.
Yeah, go ahead.
Go for it.
So remember, you have to look at your lines.
25 degrees south and
Yeah,
135 degrees east.
good job. Yeah. So I mean, yeah, it's like not exact, but so what? You don't have the lines here. So you see, they're saying it's 22 because if the line's probably going here, so you have to subtract a couple because it's obviously 20 here. So that's good though. Here you get 35. So they're probably saying the line goes up here, and so -2 again. Let's look at the next one, Sydney. So Sydney's here. It's along the southeast coast, kind of facing towards New Zealand, kind of.
34 degrees now.
Okay, that sounds pretty close. Now, you see, we're missing something here, but that's okay. You can see the line up here, and you see they're by 5 degrees each. So if you got lost, 40, 45, 50, 55. So Jose, you said 34. What do you think it is for east and west?
East and west, about 150, 150.
Okay, pretty close, yeah. So they're saying that it's more on the line. Let's do another one. Darwin, way up north, facing towards New Guinea.
Something like 14 degrees something.
Okay. Yeah, we could probably say 14, 13, yeah. And you see, once again, it goes by increments of 5, 20, 125.
130, let's like next to the line, something like 131.
Okay, yeah, 14 by 131. Good job. So which city is closest to 20 degrees south? 35, 30, 25, 20. Yeah, let's check it out. Yeah, I don't know how they say it in Australia. They call it Lagrange. I don't know. I can't do an Australian accent. It's impossible. All right. So the last couple of things we're going to talk about today is map projections. And so map projections have to do with how we see a map, like different map types for different purposes. Whenever we attempt to make a round globe and make it flat, we run into a problem. It's impossible to take a round Earth and make it look flat without stretching it or messing up parts of the Earth, especially if you're trying to keep your measurements exact. This is the part.
So that proves that the Earth isn't flat.
Well, man, I would say so. I think there's a lot of proof. If
Ah.
you're ever high up enough in an
There's literally
airplane, you will see the curvature of the Earth.
There's literally there's pictures of the Earth in a full cylinder.
Yeah, I don't think like they were photoshopping these things back when you had
Like 30 years ago.
more like 100 years ago plus. Like, I don't think people were like photoshopping it. So this leads to distortion. That's what there are several ways that a map can be distorted. Area, the size of the landmass can change. Like Antarctica in the North Pole, right? You make it perfectly flat, it's going to stretch out the bottom parts much bigger than they really are. You can the shape of land masses can change. That's another true one. Distance between land masses change. See how I told you how the lines of longitude, when they get closer to the poles, they get closer together? Well, here they don't. They're just perfect grids. That's distortion. Direction between land masses can change. And that's when you can run into problems where a map can look pretty, but if you actually try to use it to navigate from one part of the world to the other, you get really messed up. And of course, that has to do with the curvature of the Earth. So there's different map types that try to overcome that using different methods, but overall, it comes down to what it's a tool. A map is a tool. What is this tool used for? Like sometimes you need a flathead screwdriver, sometimes you need a Phillips, right? But they're both screwdrivers. I think we're going to do just one more because I wanted to keep this at 30 minutes. And then I want to show y'all if you knew how to get on the Study Island and if you know how I could give you a password and all that. So,
We know that.
yeah, it should. I mean, everybody's first time password is 1, 2, 3, 4. So,
And you can change it if you want to.
that's what he's saying. All right, let's go into the last one for the day. So here's one of those maps we call the Mercator projection. The Mercator projection is a cylindrical projection.
Right before?
Okay. So it is distorted greatly at poles and the least distorted near the equator. So you see, like look, see, this is what I was telling you about. See at the poles, they all meet together, it gets really skinny around here. But down here, they're spread apart evenly. So we know that's not how the world really is. This navigation is useful for naval ship navigation because the directions are accurate, unless they're down here. But the thing is, there's not a lot of sailing that goes along the poles. For one, the North Pole is often frozen in, where it's often impassable. And you have Antarctica in the way down here. So it makes sense because most ships are sailing between the major continents or along their own coast. So that makes a lot of sense. So you see, it's useful for that purpose. It's useful for sailing. But hey, folks, that's going to end it for today. We're going to talk a bit more about map types and things like that tomorrow. Make sure you go into Study Island and do the assignment. And if you can't get in, message and I'll help you out.